Hello again, Mr. Fitri here, coming to you virtually to finish off our first unit about introducing and understanding the Earth. This final lesson is titled Convection and the Mantle. So let's begin. Our two objectives for today are first, how is heat transferred? Okay. How do we feel heat, or how does it move from one object to another? All right. And the second objective is, how does convection occur in Earth's mantle? Again, if you recall, Earth's mantle is that middle piece of the Earth below the crust yet above the core, okay, where we have rock that is solid but very hot. Lucky for you today, we've only got one vocabulary word, and that is density. This is the ratio of the mass of a substance, okay, so the mass of a thing, to its volume. We write this mathematically as mass over volume, or mass divided by volume. On to objective one here. How is heat transferred? Well, what we need to understand first is that when an object is heated, the particles in the object, small pieces, the atoms of that object, begin to move faster. And as they move faster, their energy increases. So, faster moving objects have more energy. Secondly, we need to understand that heat always moves from a warmer object to a cooler object. So, when that energy moves from a warmer object to a cooler object, we call this heat transfer. Okay? The heat is transferring from one thing to another. If you look at the picture here, you see that there's a hand picking up a pot from a fire. And you see that the handle of the pot is red, indicating that it is hot. Now, if this were your hand, that warmer object, the pot, would move that heat or that energy from the pot to your hand, which is obviously cooler. It would transfer that heat and would more than likely burn your hand. Thus, we know that the object is hot. Now, that's just one type of heat transfer. We're going to look at that, don't worry. But we've got two others for a total of 3 types of heat transfer. The first is radiation. Second, convection. Third, conduction. So let's dive into those. First one, radiation. This is energy transferred through rays. Okay, an example for our concern is heat. The sun transfers heat and light through rays. Okay? We don't have to touch the sun. We don't even have to be close to the sun to feel the heat and see the light. The example I like that's better, though, is if you look to the right, you see a Thai hot pot, jim jum, right? I think we can all agree that we like to eat jim jum from time to time. It's delicious. But the thing is, when you eat jim jum, you don't have to touch the pot to know it's hot, right? No, because when you go to pick food from the pot, you can feel the radiant heat from it, okay? That is radiation. And because this is so critical for not only this term, but next term, I want you to know it in Thai. Okay, radiation in Thai, and excuse my pronunciation if it's not perfectly correct. Radiation is peramsi. Okay, peramsi. So that's radiation, the first type of heat transfer. Secondly, conduction. This is heat transfer between materials that are touching. Heat transfer between two things that are touching. The example I give here is stepping on hot sand and hurting your feet. Okay, we've all been to the beach, to the sea, taken off our shoes and started walking on the sand, only to realize that it's very, very hot. The same thing with the jimjum from the last slide. If you touch the jimjum, that is conduction. You're going to burn your hands, okay? So again, conduction is heat transfer between materials that are touching. Good. The next one here is convection. All right, this is heat transferred by the movement of a fluid or air. Warm liquid or air rises while cool liquid and air falls, creating a circular movement, okay, kind of creating a circle. So if we look to the bottom right here, the GIF that's moving around, I want you to think of this as boiling water, okay? Hot water, boiling. You see the pot, the gray area, and the fire below it, the orange below it. As the water at the bottom begins to heat up, okay, those particles, those atoms in the water begin to move faster. As they do, they begin to separate a little bit and rise to the top. The cooler liquid at the top then begins to sink. As it gets to the bottom, the heat, the fire at the bottom, heats that water up, giving those particles more energy, separating them, causing them to rise. Okay? So, again, as that water heats up, it rises. As it rises to the top, it begins to cool down again, causing it to sink or move downward. When it comes down to the bottom again, it begins to heat up, starting that process all over again, creating that circular movement. Good. So our objective review, 3 types of heat transfer. Radiation. This is heat transferred through rays. Convection, right, the movement of a fluid or air. And conduction, when two objects are touching. Our second objective here. How does convection occur in Earth's mantle? Okay, remember again, mantle, middle part of the Earth, okay, below the crust, above the core. Okay, so convection currents within Earth. Heat from the core, the center of the Earth, acts as a stove, which causes convection currents in the mantle. How does this work? Well, this causes hot rock in the mantle to rise, while cool rock in the mantle and the crust sink. Over time, this causes the crust of the Earth to move and change very, very slowly. Okay, so this is a little hard to explain, but try to visualize this by looking at the picture. Okay, the center of the Earth acts as a stove. In the mantle, as the rock warms up, heats up, it begins to slowly, very, very slowly, move upward towards the crust of the Earth. Now, like our boiling water from a previous slide, as it reaches the surface, reaches the crust, okay, it begins to cool down, causing it again to sink back into the mantle, where it then heats back up and rises. So within the mantle, there are these convection currents, okay, these circular movements warming up rock, moving upward, cooling, and sinking, and repeating the process over and over. Now, like I say here, this process is very, very, very slow, okay? We're talking about millions and millions of years, all right, to move substantial distances. Again, we will get into this a little bit more clearly in the future. So, again, if you're still a little unclear, just one quick example here. As you heat up soup, the soup at the bottom gets hot and rises, sending the cool soup to the bottom. The hot soup that has risen to the top then cools and sinks. This heating and rising, cooling and sinking starts a constant flow. Okay? And this, again, we call a convection current. Okay? It happens when we boil water. It happens even when we cook food. Okay? And it happens in the mantle of the earth. Okay? Wonderful. So overall, again, how does convection occur in Earth's mantle? Well, just like our pot of boiling water, right, hot material rises while cool material sinks. So that concludes our first unit, our third lesson. Many of these topics we will dive into, I should say, a little bit more closely in the future. Okay, so again, like I've said before, if things aren't perfectly clear, feel free to ask questions, or maybe just wait to see how we build upon these ideas and themes moving forward. Okay, thanks again, and I will see you next class. Well, not see you, I will talk to you via the internet. Bye-bye.